Super. Well, I'm going to start kicking off. Just to introduce myself, I'm Ed. I'm one of the co-founders of Hustle Badger. We've also got Susanna, who's my co-founder, on the call, and she'll be active in the chat, probably dropping in a few links in there from time to time. Great to have you all here to talk about evals. If you do have questions, please do stick them in the chat, and I'll do my best to get around to them either as we go through or at the end. Just in terms of housekeeping, yes, this call is being recorded. Yes, it will be on our YouTube in a couple of days. And we will drop you a little follow-up email with some of the links that we share as well. Please do stay on mute if you're not asking a question at the end, and it just helps everyone to hear a little bit better. So with that, I bring you AI evals. Let's talk about evals. There's a lot of people talking about evals and saying they're very, very important at the moment. So obviously, all the big names in the AI world are talking about evals because they're kind of important to AI. And kind of pushing this as the next core skill for product managers, or like something that everyone has to understand. I think if we talk about like what are evals, then probably the a simple kind of understanding of like why are they important comes from Hamel Hussain and Shreya Shankar, and they talk about generic metrics like hallucinations, toxicity, these kinds of terms that often pop up when we're talking about the quality of AI responses are quite misleading. They're used by everyone, but they're not in any way quantified. And if you want to have an AI system that generates really good output, is effectively like high quality, then you need to look at data, you need to identify your failure modes, and you need to have metrics that are specific to your application that you can track and improve over time. So, they are the only way that you're going to be able to run an AI product and drive up its quality, make it better over time. And I sort of think of as evals as the equivalent of QA, right? So we're all used to QA from a kind of pre-AI world where when you build a feature, you run QA on it, and that is a process or a set of tests that checks that you are making your product quality, you're kind of like meeting your bar for product quality. QA is a kind of works on deterministic systems, right? So it's very easy to kind of come up with tests that can be proved as like right or wrong. Does the calculator give me the right answer? Like there are very obvious answers and logical answers that can be computed to that. When you get into AI-driven systems, then your software is no longer deterministic. It's probabilistic. You can put in the same input and you're going to get out different but similar outputs. So evals are a way of looking at the outputs that you're getting and measuring the quality of output that you're getting in a kind of statistical way, in a metrics-based way, beyond just sort of like looking at it and being like, yeah, that kind of works. Yeah, that seems fine, sort of thing, which, is obviously fine, if you're running an internal automation or something, or you're doing like something where you're monitoring every output, but is not going to cut it if you are deploying AI systems for large numbers of external users. So that's sort of like functionally what we're trying to do is like we're trying to improve the quality of AI, and particularly as you start making more complex AI systems with maybe multiple different AI calls with very complex prompts, with maybe data processing and things in between. Every one of those steps is going to introduce variation into the output that you get. And if you double the length of your prompt and make it much more specific, do you know if that actually makes it any better? Well, without some sort of systematic measure of quality, without defining what good looks like, then you're not going to have any idea. So that's sort of like high level what evals are. I sort of think that, if you are building AI applications, then there are a few different levels that you might be doing this quality assurance process, a quality checking process on. And they increase in both the amount of effort they take and also the amount of rigor, or kind of how robust and how good they are. So at the kind of like most basic level, if you are building something like a custom GPT, so something you're going to use yourself, then you're going to do effectively kind of like, what I call like a vibe check, super quick, informal checks. You notice that you're using the same prompt a lot, and you're like, wait a sec, I'm just going to create a custom GPT for this. And then as you write the custom GPT prompt, you're like, wait a sec, I can make this prompt a little bit better. And so you stick some extra stuff in there. And you don't really test it systematically. You just have, one or two kind of classic cases. You maybe like run the prompt that you were going to run anyway. You run the input that maybe you did last time. You're like, yeah, that seems like it's kind of working. It's doing what it's meant to be. This is also, really good if you're kind of doing simple internal automations. So for basic AI apps or automations where they're exposed to few people, the kind of scope of the agent or the AI is pretty narrow. You want to spot like very obvious flaws, and you're just getting going in the development cycle. This is sort of where you start. As you kind of build complexity though into that system, and you maybe want to kind of like get it even better, then you kind of need to go beyond that sort of like very, very gut feel approach. And so if you are starting to think like, oh, I'm kind of semi-productionizing, like it's not just me looking at this automation or this agent, like there's a few other people looking at it, then generally you start to kind of get another level where you say, actually, I kind of know there are like half a dozen or a dozen test cases that this needs to perform well in, because I've tried them myself or other people have tried using them. So I will just have some kind of spreadsheet where I've got all my test cases, and I'm going to, every time I make a major update to my system, I will run through those test cases and see what the output is like and if they work or not. So you get to this sort of like a small set of test cases where you've actually thought about what those test cases are, and you're kind of running through them consistently, but you haven't really automated the process in any way, right? So this is kind of like a little bit more thinking. It's clearly much better than the kind of like vibe evals or vibe testing, but you're still quite a long way off something that's really kind of robust and metrics based. And so the kind of final level, what we're going to talk about a lot in this call, is effectively metric-based evals. So here we're talking about large-scale test suites, so hundreds or thousands of test cases that you've got from live data or you've built from synthetic data. And because you've got so many test cases, you can then score those against multiple dimensions, multiple evals, and you can see overall, like, are you passing or failing those evals? And when you compare that across a large number of test cases, that's effectively going to give you a pass percentage, a quantified measure, which you can then improve over time from version to version. So this then becomes really important for systematically improving the quality of your product. But when you think about the kind of setup required to gather the test cases, to design the evals, to then build in running those evals into your application development process, there is significant investment in here. So this is not something that you're going to do unless you really are kind of launching production, ready AI products, or your products that where the risks are high, it's exposed to lots of users, the quality needs to be good for all of them. Another way of thinking about this is, or kind of like saying that same thing in a slightly different way, is evals only make sense for complex AI systems. And if I think about sort of workflows or software in general, like fits on a spectrum from being more deterministic to more adaptive. So on the left-hand side of the scale here, you've got very simple workflows. this could be a, a Zapier kind of workflow with no kind of front end. It could be a a CRM piece of software or something, 2-3 years ago when, pre kind of chat GPT, where you've just got deterministic outputs. Now, in that case, you're doing QA, right? In this kind of like workflow scenario. If you start to add in some AI steps, again, but with a fairly linear flows with quite narrow scope for each of the AI steps, you've got what I would call an agentic workflow. Then here you've got something where you might be doing that kind of like, whether depending on whether this is internal or external number of users, you're going to be at levels 1 and 2, that kind of like vibe kind of level of checks, or you're going to be at that sort of light level of evals. But then if you get to this kind of agent level, where you've really got multiple agent steps, you've got LLMs actually deciding which tools they're going to pull, which bits of knowledge they're going to use. Here you can see that clearly that just the scope for the AI to give you back an output that is not what you want or is not appropriate for you as a user increases dramatically. So it's in that kind of case, this case on the right, this kind of agent case, that evals really come into their own. So I say it's same way of saying this, different way of saying the same thing. The amount you're going to invest in evals is going to be related to how complex is the AI system that you're building. So there's a few different ways then that you can do testing on AI products. You can have pretty simple kind of code-based. So even when you're looking at non-deterministic output, you can still run code-based, objective, logic, based rules to see if the output meets the criteria. So if you've asked your AI to, give you a JSON output, you can test if it's actually kind of valid JSON. Or you can do a kind of, a check to say, like, have we exposed any email addresses or any kind of personal identifiable information, PII here. These sorts of checks are, very clear. They're true, very clear, true or false. They're cheap. They're fast. These are great. Okay. The second type you've got here are LLM-as-a-judge. So in this case, you're going to ask something like, is the tone appropriate? Is the agent accurate? Is it answering the question? And to begin with, you're going to look at the response and you're going to grade that yourself as a human. But as you scale up, what you want to be able to do is train a separate LLM, so an LLM that's just judging the system you're building, and your judge is going to kind of grade the response and say, like, yeah, it passes, or no, it doesn't. And this works because your judging LLM isn't trying to generate the output, right? It's just going to kind of monitor a single failure mode. And it's not going to say, hey, this is a great output. Yes, 9 out of 10. You're basically going to ask it a very narrow question. Like, so you're going to say, hey, is the language in this age appropriate for 13 to 15-year-olds? Or you're going to say, like, is the length of answer correct? Something like this. Has it accurately responded using the knowledge in the knowledge database? And again, you might have specific test cases there, right? So that's your sort of like LLM-as-a-judge. You're converting what would be qualitative metrics into kind of binary responses. Yes, it's this, or no, it's not that. And then you can scale those up and convert those into a quantitative measure. The other thing that you can do, and we shouldn't forget, is like you can run A/B tests, other sort of outcomes-based tests on your product. So evals test the outputs of your product, like what is the response the user gets. They don't actually tell you what is the business impact that your changes are causing. And particularly if you're a product manager, you care very much about the business impact, the commercial impact of the work that you're doing. So just to be kind of clear, when we talk about evals, they are not the be all and end all of designing AI products. I mean, in some senses, they are if you just want to make the AI product. But if you're talking about developing AI products as a commercial pursuit, they do not solve the problem of like, are you generating the business outcomes that you want? You are still going to have to run those outcome-based tests where you look at, you know, what is the average session length? What is the retention rate? What is the churn rate? What is the conversion to pay rate? Like all these sorts of things, and check that actually, yes, as you're getting better output, you are also getting better commercial returns. So evals, we're really talking about output kind of measures here, like quality measures, in the same way that you talk about QA. QA is not going to tell you if your product is going to be commercially successful. Similarly, evals will not tell you if your product is going to be commercially successful. So I'm going to run through then how you'd actually set up evals for a product and you know, what the cycle would be. And there's 4 steps to this. First step, you're going to collect your traces. So a trace is effectively the conversation that a human has with an AI system. And you need those are going to be your test cases, effectively. The second thing you're going to do is, given a bunch of traces, you're going to analyze those, you know, as a human, and you're going to identify what are the errors that pop up. So you're going to classify the errors that appear. Once you've seen which errors appear and you've classified those, then you can design evals to test for those errors that appear. And then once you've got your evals designed, you can run your evals across your test cases every time you change your system. So you can effectively integrate your evals into your software development process. I'm going to run through each of these steps in quite a bit of detail. So if this seems a bit kind of high level, don't worry. So firstly, collecting traces. So a trace, yeah, it's a record of what happened during one interaction between a human and an AI system. So that includes, what did the user input? What internal steps did the system make? You know, sort of like calling tools or processing data. It's going to include the final output that the system gave back to the human, and it's going to include like metadata about, you know, what device were they on, timestamps, all that kind of stuff as well. So it might look something like this. You can see kind of all the different steps here on the trace tree, and you can kind of click into each of those and see actually what is going on, like which information is being passed system to system. You know, where are the calls here? You can see there's a bunch of calls to GPT-4o Mini. So this is something like what a trace is going to look like on a, you know, complex AI system. Obviously, the simpler your AI system is, the simpler your traces will be as well. Now, these, as you collect them, you're going to start collecting effectively like happy paths versions. You know, these are ones where you know, that you'd be testing if you were just like using it yourself, dog fooding it, you know, doing your vibe coding checks. Like these are kind of like the obvious test cases to include, and you're just going to kind of capture them somewhere and put them to one side and be like, great. Yeah, this is the kind of test case I'm trying to make work. This is the happy path. Let's just save that somewhere. That's going to be fine to kind of maybe as an MVP, but really quickly you want to start getting live data. So you want to get some data from how users actually use your product, because yeah, as we know, nothing quite like live data, nothing quite like contact with customers to throw out all your assumptions. And this is just going to like show you actually what is going on. What are people, you know, asking your product, and what are they getting back? Does that look good? So you want to start capturing live data as soon as possible. And if that means kind of releasing ridiculously early with a, you know, a small beta test group, if it means kind of getting everyone in your company using your AI product, you know, do that so that you can start getting, you know, 50, 100, 200 test cases that you can then use to run your evals against, and to use as test cases. The other thing that you can do If you do want to release this publicly, but you want to ensure that there's some, some kind of minimum quality bar there before you release it publicly, is you can generate synthetic data. So I'll go through this in a little bit more detail, because effectively what you're going to do is you need to have some product intuition here, but you need to kind of think about how do typical user inputs vary? What are the dimensions they vary across? And I'll explain that. And then you can create kind of the variations across those different dimensions to generate, artificial test cases that kind of explore the whole set of possibilities that you could have. Listening to myself say that, I realize it sounds very, very abstract. So let's look at that in a bit more detail. Generating synthetic data. So the way this works is like, firstly, warning. This is only going to work if you really understand your domain, and you therefore have really good hypotheses about where your product might fail. Right? If you know nothing about your users and nothing about how they might use your product, garbage in, garbage out. This is not going to work. But if you can speak to a few users, if you are a user yourself, if you've got domain experts, actually you can start to put this together in a fairly logical manner. So the first thing you do is you want to define dimensions, as I say, that the human input varies across. So if we imagine we're building an AI agent to recommend travel itineraries, then the dimensions that you might ask for a travel itinerary as a human, you might have a different destination types, you might have different trip lengths, you might have different budgets. So one person might say, oh, well, I'm looking for a city break and it's going to be a weekend and my budget is £2,000 for the weekend. And someone else might say, oh, I'm looking for a beach holiday. I want it to be 2 weeks long and I've got £500 per person. Okay, so those are very different queries, but they're obviously both applicable to a travel itinerary agent. So as you mix up these different dimensions, you're going to create tuples. So tuples are these random combinations of these dimensions. So destination type, city, nature, beach, trip length, weekend, 1 week, 2 weeks, budget, mid, low, high. You create different combinations of those. So one tuple then is city, weekend, mid. The second one is nature, 1 week, high. And you can obviously create then a huge number of these different tuples, all of which are slightly different from each other. So you're trying to create like unique versions of these tuples to give you some variation in your test cases. These tuples, you're then going to convert into natural language. So you probably want to kind of use some kind of prompt there where you can say like, hey, actually, given these are the dimensions, given this is what we're doing, convert these tuples into some queries. So this first one, city, weekend, mid, becomes plan a romantic weekend in Paris for two, staying somewhere nice but not too expensive. That's what a human might write. This is actually I generated this kind of example query with an LLM. So that's something, if you've got then a long list, you've got 100 tuples that you want to convert into queries, you can do this at scale, and you're then going to manually review these as a human and make sure that these seem kind of sensible as inputs, that the language seems human, that you're removing any awkward tuples that just don't seem like they make any sense. You're removing duplicates, right? So it's not as good as live data, but it's a really good way of kind of generating some, a large number of, kind of artificial test cases, which are going to test your product in sensible ways. So this is why kind of, synthetic data, or how synthetic data kind of makes sense. So having gathered your traces, so maybe you've got some live data, maybe you've kind of generated a bunch of synthetic data. The next thing you want to do is run your error analysis. Now here, you'll see what I'm imagining here is you've got all your test cases here. I've put 8, but let's imagine there's a couple of hundred. Let's imagine for each of these, you've got the full trace. I've just put the initial user input, but remember your trace is going to include what you get back and everything else. all the steps that go on under the hood in your AI system. As you look through those traces, the first thing you're going to do as you do your error analysis is just make some qualitative notes on how it performed. So this has to be done by human review first, and should be done by someone who's domain expert. If you were going to do this mechanical Turk style, where a human gave you this input, and then you had a domain expert behind the scenes, kind of Wizard of Oz style, like giving the output, how would they grade how well the AI did? You may well see multiple failures, or like multiple things going wrong. If that is the case, and particularly if this is like a multi-step process, go until you get to the first major failure, right? That's the one you want to focus on. Why the first one? Because as soon as you get one failure, then the AI is probably going to kind of exacerbate that problem, make it even worse in future steps. So there's not much point going beyond the first failure. And you want to write, fairly brief, because you're going to have to write it and read it, and that's going to take a lot of time. But descriptive notes, so you've got like an idea of like, oh yeah, what's going on? Why is this a problem? Why is this unexpected? So this is kind of your first set. You then have an annotated set of test cases where you can go like, okay, this is what we got back currently, and these are the problems that we're seeing. Now, once you've got those qualitative notes, then you're going to start clustering these into groups. So that's called, you're kind of making a failure taxonomy. So you might have one failure mode, which is the budget recommendation from the AI system is not what the user asked for. You might have a response where the AI system didn't meet the constraints of the human. So maybe here you can see like test case 4. Oh, we asked for a vegetarian itinerary. Maybe it wasn't vegetarian. It included sushi. Okay, well, that's not going to work for the user. So you create these different categories, and you can adapt that over time, right? So you can, if you've got too many, you can kind of like merge them together. If you've only got 80% of all your failures in one category, maybe you can kind of split it up and be a bit more refined about what you're seeing. But you're going to kind of like work out like what are the main failure modes that you see that you want to try and fix. Having done that, right, then you can take a call like, okay, this failure mode that we're seeing. So for each of your failure modes, maybe you've got 5 or 6 of these. You want to go through and kind of classify it as one of two things. The first thing is it a specification failure? As in, is this, you don't like the output, but actually what you asked the AI to do never specified that this was a problem. So you're looking at the output and you're like, oh, wait a sec, this is like 3 pages long. And actually as an itinerary, I want a bullet point list that is, no more than 10 bullet points. Okay, great. But if you didn't tell the AI that you only wanted bullet points, then this isn't really kind of a problem that you need to solve with evals. You just need to go and fix your prompt and then see if it still appears. So anything where you're seeing problems that you haven't kind of given the AI enough context, fix the prompt first, because that might just be a very, very quick fix, and you don't need to go through the labor and the effort of creating evals to solve it necessarily. Okay, it's a bit like ask an engineer to build you something and you miss out half the requirements and they build something you don't want, right? That's your fault. Like you need to give them the right requirements. So the second type of thing you might see happening is generalization failure. So you've given really clear instructions and then something unexpected or undesirable is happening. So these are what your candidates for evals are. Things where you're like, I thought I was being really clear. I can see this in the prompt. I can see this in the code, but we're dealing with non-deterministic systems, and therefore unexpected stuff is happening for reasons that are quite hard for us to find, to work out why. So this is likely to be a persistent problem for some time and going to have to require us to kind of like work away at it to improve it. This is where you want to focus your evals. Okay, so we've gone through the first 2 steps there. We've gathered our test cases. We've worked out what the failure modes are. Now we're at the stage where we're going to design our evals to test each of those failure modes. And as I mentioned, there's basically two ways of doing this. You could have code-based, or you could have your LLM as judged. So for the code-based ones, like these are ideal, right? You want to use as many of these as possible because they're cheap and they're fast and they're deterministic. They're right or they're wrong. So if you can figure out a code-based way of identifying that failure mode, then use it. Like, don't get fancier than you need to. And if you can, like, if you've got a code-based rule, then often you'll be able to write that, so that it runs every time a user uses the system. It doesn't need to be an eval that is run in test batches. You can basically just kind of like build this into the system and be like, okay, actually, like the user asks us this thing, we've run a test against this guideline, and if the guideline's not met, we ask the AI to reprocess it, right? And we have some kind of way to correct it, or we kind of edit the response and provide some kind of answer. On the LLM-as-judge side, here you're going to use this for ways where, as a human, you can be like, yeah, I can spot this as a problem, and I can judge this as a problem, but I can't really define kind of clear logic or kind of a kind of rules-based test that we could run every time. So here we're going to design an LLM with a very, very narrow focus to judge whether the response passes the criteria or not. Is the tone appropriate? Is the agent accurate? It's these sorts of kind of qualitative assessments. But you're designing for a binary pass-fail, right? You're not going to say like, hey, how good is the tone out of 10? Because LLMs are not very good at doing that. Like they're okay at doing the kind of binary, yeah, this is appropriate, this is not appropriate. When you give them, like, it's not appropriate if it includes swear words, profanities, blah, 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 blah. You can kind of list out, you can give it like really good context on it's appropriate or not. But yeah, creating a graded scale is just an extra level of complexity that's not worth getting into. You can also, you're going to calibrate your LLM as a judge. So what do I mean by that? I mean, when you set up this eval, when you set up your judging LLM, you're going to calibrate it by giving it a bunch of responses and getting it to decide, are they right or not? And you're going to look at those responses as well and also say, does it pass, fail? And then you're going to compare your answers against each other. And there's two metrics that you want to look at there. So TPR and TNR, so true positive rate and true negative rate. So how often, or what percentage of the times that you say it's a pass, does the LLM say it's also a pass? And what percentage of times do you say it's a failure? Does the LLM say it's also a failure? Right. So those are your two metrics that are going to kind of tell you how good your LLM judge is. It's not going to be perfect, but again, you should be able to kind of like do a few quick cycles there, tightening up the system prompt, so you get it to a good enough like level where you're like, yeah, this is good enough to kind of, I trust this like at scale to give me the results that I want. And again, this is something where you just as you're testing your system that you're building, you're going to test your judges on a regular kind of cadence as well. So when you've done that, you're then into kind of, you can then run your evals against your traces, right? So you can imagine we've got all our traces here, and we've developed these narrow evals, 5, 6 of them, right? Not like, obviously these, you don't want to have too many, because the more that you have, like, the less clear it's going to be to you as a product manager where you try to optimize or which ones you try to make better, because you're often going to have trade-offs between, like, if I make eval 1 perform really, really well, then maybe it's much harder to get eval 2 and 3 to perform as well. So, you're looking for, it's a bit of a judgment call here that, what's the sweet spot of how many evals give you a good enough coverage of your main failure cases, but you're not having like so many evals that actually it's impossible to decide if it's got any better. So let's say we've got 4 evals here. We run them against the output we're seeing, against traces we're seeing. And again, we're getting binary outputs, pass, fail, whatever it is. We can then work out, for this version 1, what is the pass rate? Like, what is the pass rate against the evals that we get? So here you can see like pass rate for eval 1 is 75%, pass rate for eval 2 is 75%. Great. We then go and change. We're like, oh, actually, yeah, we see we're not doing so well against eval 4. I think, when we look at that, probably we can just update the system prompt. We can change the model we're using. Maybe that'll make things better. Then we're going to come up with V2. We're going to run our evals again. Then we, make some more changes. And then we're going to run, the evals again, on V3. And over time, you're going to be able to use these metrics to compare between versions to see if you're heading in the right direction. Okay, again, the goal in here is not to get to 100% on all your evals. The goal is to make sure that you are improving, every iteration to make sure that you are making the product systematically better. And I'd say you're going to run your evals in 2 ways. Like, firstly, on this kind of static bank of test cases that you've created. I mean, I say static bank, like you're going to add new cases to it over time, but you've got a standardized bank of test cases that you run your evals against so that you can do this comparison between versions. But then also, ideally you want to run it against live data, like on a regular basis. So every week you run, a random selection of 20, 50, 100 user cases, because that's going to catch new failure modes you haven't seen before. It's going to catch drifts in user behavior and other emerging behavior. So 2 ways you can then use your evals to flag up problems with the product. If you've got that far, then you kind of on to your final step, which is then integrating your evals into your software development cycle. So as I mentioned, you're going to, like, every time you make a change to your prompts, your tools, your code, like the UI, you then run that variation against your test case. You might do that against each version. You might do that weekly. It depends how expensive it is, because remember, each of those evals it's an LLM call, right? So running, 10 evals on 1,000 test cases, you're suddenly running like a large number of LLM calls, which is going to start having a significant cost if you're not careful. So again, you're going to have to be a judge of like, what is the cost benefit of running your evals, more or less frequently. But you're going to run your evals. You're then going to track progress over time. And based on how you see things, you're going to keep iterating. Or maybe you'll roll back to a version where, oh, actually, that made this eval worse. So maybe we've lost something. Maybe we need to go back, right? So you're into this then kind of fairly typical product improvement cycle, iterating, testing, measuring, and so on, round in a cycle. So that's kind of broadly it. That's what I wanted to cover as the basics of evals. I hope that was pretty useful. Just to wrap up with some kind of takeaways. What are evals? Evals allow you to systematically improve the quality of AI applications. How do you do that? 4 steps. You gather your traces, you run your error analysis, you design your evals, and you integrate it into your development process. Evals are expensive, both to run, but to design. This is a time and cost intensive process. So bear in mind the cost of what you are doing. And with that in mind, be conscious of what is your budget for running evals? What is your budget for improving the quality of output? Because you are improving outputs, not outcomes here, right? So how much better do you want to make your output? And how much are you going to invest to get there? If you want to learn more on this, we do have a course on this starting in January. So if you're like, oh, this is great, but actually I want to go and build some evals, then our course, Deploy an AI Agent, kicks off in January. What we do over 4 weeks is we build an AI agent, like a real one that is deployed to the internet, that is live, that you can send, peers, friends, family to, and we then write the evals for them and run those evals over iterations so that you can improve them. This is like, if you're looking to build an AI product that you can put in your portfolio, this is perfect, right? This is going to be like real practical experience of doing the whole life cycle, everything that you need to you would cover in a production setting, and then having a live artifact that, stick it on your LinkedIn or whatever. If you're like, oh, this is great, but actually having heard about evals, that's a bit heavyweight for me, but I'm still kind of interested in AI. We do have a couple of other courses which are a bit more lightweight. We've got our Build with AI course, which covers AI automations, AI prototyping, and AI coding in 4 weeks. And if you want to build anything with the latest AI tools, this is an amazing starting point. And it's also great for just increasing your technical proficiency overall. And if you want to build like AI automations, agentic workflows, not a full-blown agent, but things to help you save time and automate routine work, then our course on automating with AI is going to be the one for you. With that, I'm going to kind of look in the chat, and if you've got questions, I'm going to answer them. Right into the chat here. Okay, Sudhir is asking, how much programming skills is needed to create an AI agent? Very little, basically. So if you are using a kind of workflow platform, so something like Zapier or Relay.app, these are drag and drop systems where you can pull different blocks together, and you can include AI steps, which effectively give it agentic functionality. And then all you're doing is you are writing the prompt for that AI step, the same way that you write a prompt for ChatGPT or Claude. So you do not need to have any programming skills to build your own agent. Victoria's got a question. Quick question. Do you reckon it's a good strategy to base a budget for evals based on ops costs saved from not having, i.e., actual agents answering phones? I think if you're looking at agents sort of reducing human cost, then that's going to be a really solid way of creating a budget for your evals, because you're going to say, look, our system, our AI agent at the moment can solve X% of test cases, and we free up this much time. And if we can get that from 70% to 80%, then actually we're going to save this much more cost, right? So on that basis, you're still talking a little bit R&D, right? So you're going to say like, okay, well, the size of the prize is like this much, maybe £1 million. How much do we invest in evals? Do we invest £100,000 or £500,000? I mean, we don't know, right? We don't know if that additional incremental spend in evals is actually going to give us the uplift that we want. But it does help you calibrate that you're not going to spend, 6 months working on evals and blow £500,000 on something where the total opportunity is like, £10,000. So I think it does help you calibrate, but there's no kind of firm answer for this. Jean is asking, any advice on managing evals when LLMs are updated and those updates might change outcomes? Yeah, so if the models are changing, then if it's a significant, especially if it's a significant model change, you will want to run your evals against the new model and check that it works. Often if you're building a system, like you're going to be using different models for different things to optimize performance and cost. So, you generally have like some intuition about which models are going to be better for which things. So you're going to take your best guess at it and then run your evals, and then maybe tweak one or two of the things that you think there might be some variation, and see if that improves things. So yes, you are going to test them against your models. Another question from Victoria. Are there any other strategies for cases where there's no ops cost saved as of yet? Yeah, I think absolutely. Like if you're looking at, you can have revenue-based cases, right? Where if you are selling your agent. So if I am Lovable, and I've got an agent that builds people's websites, and I charge $20 a month, then my evals are basically going to be looking at ultimately like, do people renew or do they churn? Or can I upsell them to larger packages, maybe my $50 package or my $100 package rather than my $20 package, right? So you're going to have those revenue-based frameworks as well. But just as with normal product development, right? You want to be tying back the work that you're doing to commercial outcomes. And there's only so many ways of getting those. You increase the price, you increase the number of people you sell to, you increase the retention, or you reduce the cost base. Brett is asking questions, right? What is the connection and how logically do you draw the correlation between output and outcomes in terms of commercial output and measurement? Or would you say run evals in isolation purely for model performance? Yeah, so I sort of building, Brett, you're kind of building there on the discussion with Victoria. I think in an ideal world, right, you're going to be able to find a correlation between your evals performance and commercial outcomes. Yeah, in the same way that you would have leading metrics in a traditional product, right? So if you think about, oh, my onboarding process, I know that if, yeah, I used to work at Depop, right? So social fashion e-commerce marketplace. And we knew that if we could get people to make 100 searches in their first week, they had a high propensity to then go on and make a purchase. And if they made their first purchase, they had a high propensity to come back, month after month after month and make more purchases. I think similarly, if you can say like, hey, actually, we know when users get a good response on their first query, on their first trace, they have a good chance of coming back and converting, then you've got a very clear signal there. You can say like, okay, well, we know that users have a successful response when they pass all our evals. What is the percentage of user responses that are passing all of our evals, and how do we optimize for that leading metric, right? But I think you just got to kind of accept that because you're dealing with a non-deterministic system, you might not be, you're not going to be able to optimize that metric indefinitely. There's going to be some upper limit to that probably. And so you just want to make sure that the amount of effort that you're putting into optimizing your evals then is actually converting into commercial impact. And at some point, like it's going to be almost certainly some kind of diminishing returns, right? Like when you start working on your evals, you start working on your product, you can make some quite big improvements. And then actually you kind of get into this optimizing phase where unless you're really at scale, it's just not going to be worth kind of optimizing the process any further. So thanks, David, for reposting that. What observability tool do you recommend or use for traces? Yeah, I mean, I showed a screenshot of one there. There are, 5 or 6 kind of tools out there that help you track your traces, that help you run your evals. Honestly, I have not looked at them in depth. So, Google that, ask ChatGPT, do your own research. But know that, there are multiple tools out there off the shelf that will help you run evals and help you get good results. If you're building stuff in N8N, then there is, if you're not, N8N has kind of like inbuilt stuff. So some of the automations tools are kind of building it that natively as well.